Hi friends, welcome to follow up. Let's have a look at problem 2712. Minimum cost to make all characters equal. In this video, we're going to follow the hint and give a solution based on considering prefix and suffix. So here we are given a zero-indexed binary string s of length n. So we can do the following operations. So first type, so we can choose an index I and then invert all characters from index 0 to index I. So the cost is I plus 1. So here we can interpret this cost I plus 1 as the number of characters inverted. So from 0 to index I, there are I plus 1 characters, right? So similarly, another type of operation is to choose an index I and then invert all characters from index I to index n minus 1. So with a cost n minus I. So here from index I to index n minus 1, the number of indices are actually n minus I, right? You can compute by the difference of the indices, then plus 1. So here n minus 1 minus I, then plus 1. So the total indices involved is n minus I. So we are required to return the minimum cost to make all characters of the string equal. So here invert a character means if its value is 0, so we make it 1, and vice versa. So here we have two examples. Example 1 is very easy to interpret, right? So you can choose index 1 and then convert the two zeros at index 0 and index 1 by 1. So the cost is 2, right? Or you can choose index 2 and then you can invert the characters at index 2 and index 3 to be 0. So there's also two characters involved, so it's also 2. So the minimal is 2. So example 2 is not straightforward to interpret, but here is an explanation. So we are going to look at the code and then understand this output. So here the constraints is the following. First, the length of this string is n, and it's bounded above by 10 to the power 5. So this 10 to the power 5 basically defines or determines the problem size. So s is binary. In other words, the characters are either 0 or 1. So here is a very useful hint. So basically the first two, I'm just want to mention the last one. So the final string would contain at least one character that's left unchanged, right? So therefore the answer is the minimum of prefix I plus suffix I for all the indices. So here this is the interpretation of prefix I and the suffix I. So the prefix I is the number of operations, or more precisely the cost required to make the prefix at these characters, both inclusive, from 0 ending at I minus 1, so equal to the character at index I, right? So similarly, you can define suffix, right? So this here this thing, the hint 3, it provides a invariant for this problem. So after all, so we need to change all the characters to be 0 or all the characters to be 1. So there's a certain position. So this corresponding characters do not change. So with that said, let's look at the coding part. In between, we are going to explain the logic. Let's first find the length of this string, just for convenience of writing the code. So here we are going to interpret prefix I as the cost to change all the characters from the beginning and ending at I minus 1 to the character same as si. So here 0 and I minus 1 both inclusive. So similarly, suffix I will be the cost to change the characters to the right of the index I to be the same as the character at index I, right? So first let's get this index m. Now let's initialize prefix and the suffix. So I'm going to use length m list. So now let's use two traversals or two linear scan to fix or update this prefix and suffix, right? So the prefix 0 will be 0, right? Because there's nothing to its left, and the suffix at the last index will also be 0 because there's nothing to the right. So now let's look at for I in range 1 to n. Let's first set the prefix. So here we are going to compare si to be and I minus 1. If they are the same, right, then we can easily see that prefix I would be prefix I minus 1. So this is the cost to make all the characters to be the character as in at index I minus 1, but they are the same at the index I, so this is the cost. So otherwise, so prefix I would be prefix I minus 1, so plus I, because we need to do the change. There are I characters to the left of index I, right? So this set up the prefix. So similarly we do for the suffix. So for I in range, so we start from n minus 2, so we're ending at 0. So here is the ending index non-inclusive. So here is the increment. Because it's negative, it's decremented by 1. So again, we're going to do comparison, but this time compare with the one in its right. So if this is the same, similarly, suffix I would be suffix I plus 1. Otherwise, so we're going to do suffix I equals suffix I plus 1. Then to the right of index I, there are n minus 1 minus I indices. So we're going to write it like this. And then what we are going to return is nothing but the mean of x plus y for xy in zip of the prefix and suffix. So this is the hint 3, right? So here we are using a comprehension, but in an iterator format, right? So before we make any comments, I guess it's now a time to do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So now we can examine the output for the example 2, right? So you can print out the prefix, and you can also print out the suffix, right? And for example 2 here, s is given here, and then right, you see the corresponding sums. Here's 15, here's 11, here's 9, here's 9, here's 11, here's 15. So you can, there are 2 ways essentially, and at least. So anyway, so the return is 9. So with that said, we are finishing the video for this problem. Thank you.